Are you guys able to hear me well? Yes, someone? Suhani, okay.
Yeah.
Okay, cool. Thanks. Ranveer, is your audio okay? If not, I'll be pulling up Suhani.
Oh, so can you hear me?
I can hear you. Yes, much better.
Okay.
Thank you. I checked with Dad as well. He said he'll work on it and mostly it should be fine. Okay, cool. So for today's lessons, we didn't go through the basics of permutation, combination, and probability. So we'll do that basics first, and then we'll come to the homework discussion. And I didn't have too much expectations from you that you will be doing this, but if you have been able to Google yourself and just, I mean, this is plain probability and permutation combination, or just mostly logic. You don't need too much math. Just with intuition and logic, you can still do it. But anyway, we'll discuss formally how to do them as well. Okay, so let's get started with some basics on permutation combination. Okay, so let me just. Okay, so there are two words, right? One is permutation, and one is combination. So together, this is called combinatorics, right? Together, it's called combinatorics. Combinatorics, right? So there are two parts to it. Okay, so permutation is an arranging game. It's an arranging game, same as arranging, right? And combination is a choosing game. Choosing is one or double O. I always forget choosing. Okay, fine. I'll just say one. Okay, so choosing. So choosing is same as combination. Arranging is same as permutation. Now, I would like to, Drishit, I cannot see you better. All videos on throughout the class. Okay, please. And beach mein, I see that some people turn off the videos. I don't want that. Please stay on. Right? If it's very brief, getting some water or something. Ideally, you should have done all that before. Water, washroom, all these notes and all that. Everything should be ready and set to go. Okay. All right. So there are two things, right? So now we'll be focusing on combination first, the choosing part first. Okay. So let's do this first. And then maybe I should have put this left and this right. So we'll do this and then we'll do this after this. And ideally, I would like to keep both of them separate, right? Because they are actually separate things. So what is this choosing thing? So choosing thing is, so let's say there are 7 kids in class, right? So A, B, C, D, E, and intentionally I'm drawing that randomly here and there just to dispel any notion of arrangement. There's no, it's just randomly arranged chaotically, right? And the teacher has to select 3 students, okay, to represent the school, something. Okay, now what will she typically do? Okay, so she'll call out one name. Let's say she calls out F, and then she calls out C, and then let's say she calls out G after that. Okay, now this is one way in which she could have selected 3 students. In another situation, she could have called out C first, F next, and G. But technically, these two are the same groups because the ordering itself does not matter. Whether she calls F first or whether she calls G or whether she calls C, it's still the same group of 3 kids, right? But in how many ways can she, for the first group itself, for her to call F, when she made that initial decision of the 7 kids, who should I call out? She had 7 choices to pick from. After F was pulled out, she had 6 choices to call out the next person, 5 choices after that. So it's tempting to think there are 7 into 6 into 5 ways to form groups of 3 until we realize that these 2 groups are exactly same. So there's no difference at all. So we are definitely excess counting, right? Divided by excess counting. So we want to normalize for the excess count. So how much excess are we? By how much are we excess counting or double counting? Double counting is a naive way of saying it, when literally you're counting everything twice. But this is extension of double counting. It's excess counting. We are actually counting in how many ever ways we can arrange C, F, and G between themselves. So many times you're counting. So let's write. So that brings out to the arrangement part. So let's say I call out. Let's write it alphabetically. It could be C, F, G, C, G, F. FCG, FGC, GCF, GFC. So there are 6 ways. Where did the 6 come from? The 6 came from 3 factorial. And where did the 3 factorial come from? 3 factorial came from, imagine we had the group of C, G, and F. Who could we have put first? It could have been any one of the 3. Who could we have put second? We have put third. So that's the 3 into 2 into 1. So in summary, if I already have a small group that's chosen, the way in which I can arrange them is 3 factorial ways, right? And that's the number of times I'm excess counting, right? Does this make sense? So we are excess counting by 3 into 2 into 1. Okay, now this notation of 7 people, we are selecting 3, is notation as it's typically people write it like this: 7 choose 3, or sometimes people explicitly write 7C3. 7C3 means from 7 we have to choose 3. So this is just notation. Okay, so clear so far? Now, so likewise, for example, it is 12 choose 5. How will it be? So it'll be 12 into 11 into 10 into 9 into 8. By the excess counting in that case would be 5 into 4 into 3 into 2 into 1. Okay, at least the bottom I can write it conveniently as 5 factorial, but in the top it's little clumsy if I have to, especially if I'm dealing with 100 choose 20, right? It's too much for me to write at the top, right? 100 into 99 into 98 and all that. So now people devised an easier way. So here, rather than write 12 into 9 into 10 into 8 into 7 all the way till 8, so people said we can instead artificially multiply and divide by 7 factorial, because I can multiply numerator and denominator by any quantity, right, without disturbing it. So I choose to multiply by 7 factorial. Why? So that numerator becomes the full sequence from 12 all the way till 1. So that's 12 factorial. All of you know factorial, right? Factorial is the product till 1, going back. Okay, 12 factorial.
Initially, why do you stop at 8?
Because I'm choosing only 5, right? 12, 11, 10, 9, 8. There are 12 kids. I have to select 5.
Yeah, correct. Okay.
Yeah?
Yeah.
Okay, so I can write it as 12 factorial upon 5 factorial times 7 factorial. Okay, so similarly, I can write this as 100 factorial upon 20 factorial into 80 factorial. Okay, more generally, we have n people of which we have to select r. So it's notated either like this or like this, n choose r. So this is n factorial. N is a bigger number than r. It could be equal to r at max upon r factorial times n minus r factorial. Okay, this is clear. Now, okay, let's take with let's do some basic operations with choosing, right? Suppose I have 7 choose 1. Okay, what is the meaning of this? You don't have to necessarily always go with formula. Of 7 people, how many ways can I select 1? Any kindergarten child will tell you that's 7 ways, right? It's no brainer. There are 7 people. I have to pick one. It can be literally in one of the 7 ways. But will the formula also give us the same? It'll be 7 into 7 factorial by 1 factorial into 6 factorial. Sorry, yeah, correct. Right, which will be 7 factorial is 7 into 6 all the way till 1, which will cancel off with 6 factorial except for the remaining 7. So the formula is giving us consistent result only. So 7 choose 1 is 7. What's interesting is 7 choose 6 is also 7. So just imagine there are 7 students. I'll have to select 6 students, right? Or in fact, let's go to the extreme. Suppose there are 100 students. I'll have to select 97 students. Will the teacher select 97 students? She'll instead say, these are the 3 students I don't want. By her picking which those 3 students aren't good enough, she has automatically picked for the good students, the good 97 students that she wants in the school group. So in other words, 100 choose 97 is same as 100 choose 3. So for her to select 97, it's as good as for her to select 3. For her to select 1 out of 7 is same as selecting 6. So just imagine if you have to select 6 from 7, you would not select 6. You will just instead say who is the eliminated guy. And automatically the remaining 6 are the selected ones, right? So more generally, n choose R is same as n choose n minus R. And the formula also tells that, because if it's, for example, let's go with 100 choose 97 itself, right? The formula says it's 100 factorial by 97 factorial times 3 factorial. Here the formula says it's 100 factorial by 3 factorial times 97 factorial. Only the ordering of the R factorial and the n minus R factorial in the bottom are interchanged. But numerically, it's the same value, right? And intuitively also, it makes sense. Choosing 3 is same as choosing 97. I'm not arranging, I'm only choosing, remember. With choosing, without any notion of arrangement, choosing 3 is same as choosing 97 from a group of 100. Okay, what about choosing 0? Okay, Yuvam, from 8 students, in how many ways can I select 0 students?
There can be like infinite ways.
Infinite ways. Why?
Or there can be like no way, because like you can't select, but you can select 0 student, because like 0 can be selected from anything, which is like great. 0 can literally be selected from anything, so there can be infinite options.
Okay, hear me out clearly. What is my question? There are 8 students. I'll have to select 0 students. In how many ways can I do it? So you okay. So you are saying infinite. Okay, that's possible. Okay. Does anyone agree or disagree? Ranveer, what do you think? Navya, I saw your point, your hand. That's right. Just hold on 1 second. Yeah.
So you said how many ways are there to select 0 from 0 students?
0 students from 8 students. How many ways?
Oh, 0 students from 8 students. Like I would either think it's infinite or like 0.
Okay. So can you, when you say infinite, you should be able to name the first few, right? Can you start listing out? Just imagine there are 8 of us in class right now, right? In how many ways? Start with the first few. How many you would call 0?
I don't really know.
Yeah.
Sir, actually, I think that there are like no ways, because like you can't.
Okay. Okay, so no ways, so 0 ways. Okay, okay. So from infinite, we have gone to 0 ways. Okay, Veer, what do you think?
I would say 1 way,
Okay, 1 way. Okay, Veer, why do you think it's 1?
because if you're selecting 0 from 8, that means that that's still a combination.
Exactly. The act of not selecting anyone is 1 act. In 1 way, you can select by saying no to everyone. You can do that in exactly 1 way, right? And this is exactly same as 8 choose 8, right? The bottom 2 numbers add up to the same quantity, like 1 to the quantity at the top. 1 and 6 add up to 7. 97 and 3 add up to 100, right? 0 and 8 add up to 8, right? So 8 choose 8 will be same as 8 choose 0. 8 choose 8 is easy to understand. From a group of 8, in how many ways can you select 8? Only 1 way. You literally have to select all of you are in, right? There's no choice. You literally have to take everyone in. There's only 1 way, which is easy to understand. But selecting 0, I can understand. It's a little hard to intuit. What do you mean selecting 0, right? It means just rejecting everyone, just saying no. That's it. That act of saying no can be done in exactly 1 way, right? That's 8 choose 0. Doesn't make sense, guys. Yuvam, Ranveer. So 8 choose 0 is 1. Okay. So that begs the question what 0 factorial is, because by formula, this will say 8 factorial upon 0 factorial into 8 factorial. And by formula, this guy will be 8 factorial upon 8 factorial times 0 factorial. You know, 8 factorial cancels. Intuitively, we know it's 1. Therefore, 0 factorial is 1. I mean, not that therefore 0 factorial is 1. There's one way to think why 0 factorial is 1. Okay. Again, if you start going like from 0, how can we go back to 1? Factorial means you keep going back till you reach 1. 5 factorial is this. How can you start with 0, which is already past 1, and reach 1? You cannot, right? So, but we all have accepted that 0 factorial is 1. Okay. So that's choosing. Okay. Now, arranging is, as we just saw, arranging is much simpler, right? Arranging is just, there are R people, okay, already selected. Okay. So in how many ways can they arrange? What do I mean by that? Let's say 1, 2, 3, 4, 5. There are there are 5 seats, right? You remember there were 12, choose 5, right? Of 12, I had to select 5. So now I've selected those 5. There are 5 seats laid out. So let's say the selected in another group, let's say P, R, M, T, and U are the selected letters from, let's say, A, B, from the latter part of the alphabet, something, right? P, R, M, T, U. All right. Now these 5 have to be laid down on a straight line. In how many ways can be they laid down? So you can call anyone to occupy the first spot. Yeah, Veer. Sorry, go ahead.
Yeah, I would say it's 5 factorial.
5 factorial, right? So you can put anyone here, you can put anyone here, you can put anyone here, anyone here, and anyone here, right? So 5 factorial base. So arranging is much simpler. It's just simply multiplying by 5 factorial. Okay. Now, in some problems, the choosing and arranging would come together. I would urge you to keep them separate. So keep the choosing part separate. For example, it could be that, right, again, the 12 people, you have to arrange them in, first of all, you have to select which 5, and then you have to arrange them. Let's say, then you'll have to first select, which is 12, choose 5 ways, and then arrange them in 5 factorial ways. So that'll be the number of ways in which you can choose 5 and then arrange together. That's just multiplication, right? But if you see, for someone who didn't know all this choosing business and all that, what would we normally do? Let's say there are 12 entries, right? I think starting from N, we have N, O, P, Q, R, S, T, U, V, W, Z, right? All the way till Z. There are 12 or 13 entries. Let's say it's 12, right? So I'll have to arrange, I have to pick and arrange them in these 5 spots. I can call any one of the 12 to occupy the first spot. 11, 10, 9, 8. That's what my answer would be, right? Why do I need all this choosing business and 5 factorial business and all that? It's 12 into 11 into 10 into 9 into 8. Let's check if that's what the formula gives. So this is 12 factorial by 5 factorial into 7 factorial. When we multiply by 5 factorial ways of arranging, the 5 factorial gets cancelled off, leaving 12 factorial by 7 factorial. When you do 12 factorial, it's 12, 11, 10, all the way till 1. So 7, 6, 5, all the way till 1 gets cancelled, leaving just 12, 11, 10, 9, 8, which is goom, ke, we have arrived at the same thing, right? So 12 choose 5 into 5 factorial is nothing but a product of starting from 12 for 5 numbers. This is also notated as 12P5. Just know it for now. I would strongly discourage someone using P because it's very confusing, right? Keep the choosing part separate, keep the arranging part separate. However, be aware that something called P, 12P and NPR exists. So NPR is nothing but first choose and then arrange them. Okay. Right. Okay, so now I think that's pretty much good start for us to start discussing the homework problem. So let's discuss, and then as and when there are gaps, we'll fill it. Okay, so let me go to the very top here. First question from the this thing. List the number of ways in which 4 people A, B, C, D could line up, right? So we already know by now there are 4 factorial ways in which they can be lined up, right? So we don't have to list them, but we should know that there are 24 of them, right? 24 in which orders in which they can be lined up. Now, if they line up at random, determine the probability that A is next to C. Sanvi, were you able to do this one?
Sir, I didn't get time to do this worksheet.
Okay. All right. Arav, how about you?
So no, I did not finish this one.
Okay. It's partly my fault too. I gave the homework very late in the week. Okay, Drishit.
Yes, I too didn't get time.
Okay. Okay. Aditya.
So I got 5 upon 12.
5 upon 12. Okay. Tell me what did you do to arrive at 5 upon 12? A is okay. By the way, probability is nothing but a combination. It's a mix of permutation and combination, right? The denominator probability is number of favorable cases, right, upon total number of cases. That's all probability is, right? Without any restriction, whatever it is, that's the total number of cases. That's the denominator. Now, specifically, we want some specific arrangement, some specific restriction. That's the numerator. Okay, so 5 upon 12 is what you say. Okay, go ahead, please. Please explain where the 5 upon 12 comes from, Aditya.
Yes, sir. So basically, if you put C at each position and you place A accordingly, you see that there are 10 possible 10 possible outcome 10 possible ways in which you can place them accordingly. And
So
then one
okay, so literally you wrote them out all, is it? Like you wrote like CA here.
so when I saw the pattern of the first two, then I just did it in my mind, and then I got 10, and then I did 10 upon 24.
Okay, okay. But let's just imagine there are, instead of A, B, C, D, there are A, B, C, D, E, F, G. Like there are 7 students, all right? 7 people. Then it becomes little more complicated. Don't you agree?
Yes, sir. So then otherwise, then we can do like in the first position, then we can use I use like the thing called dash method. So like basically in the first position, there's 1, which is C. Then
Yeah.
in the second position, there again has to be 1. Then in
Okay.
the third position, there can be 2, and in the fourth position, there has to be 1.
Okay, so basically you're saying in the first position you want C, in the second position
Yeah.
you want A, and then third position you have freedom. It can be either B or D, and the fourth position you've lost that freedom. Whoever it is, it'll fill it up. Now
Yes, sir.
this is now after that, what will you do?
So then you can interswitch the position. So like the first becomes 1, which is A, and the
Yeah.
second becomes 1, which is C.
Okay, and then
third
the same thing, right? So 2 into. So basically A and C can be swapped. So that's 2 into. Now you'll move to the second and third spot, is it?
Yes, sir.
Okay, all right. So having done all that, you've got 5 upon 12. Okay. Yuvam, what did you get? Your
Sir,
hand
I'm
was up.
sure about my answer, but I got 1 upon 2.
1 upon 2. Okay. What is your logic, Yuvam?
So what I didn't know this method. So
That's
like
fine.
like since it was like only 4, I list down the factors quickly in like 5 minutes. And then I counted all of them where A is next to C or C is next to A.
Okay. You literally hand counted them. Okay, sounds good. Suhani, what did you get?
Oh yeah, I got the same as Eva. I did the same thing as him because I wasn't sure how to like do
Okay.
it.
All right. Navya, what you got 1 upon 2 as well?
Yeah, but
What did you do?
I did so I took like A and C since they're next to each other, I just took them as like one unit, like one person.
Yeah.
And you have 3 people basically because A and C are together.
Yeah.
So then that's factorial. So I got 6 for that. And then A and C can like alternate, like they both can switch places. So I do 2. So 12 by 24.
Perfect. Very good. Very well explained. I'll explain it to class again once more. But before that, Ranveer, you had something to share?
Oh wait, so I'm not sure. I got 1/4 though.
1 over 4. Okay. All right. So we have a few different answers. Couple of people got 1 over 2, but let's discuss, right? So yes, hand counting is good, Yuvam, but obviously that will work only with a small set of numbers. So immediately, if I say like a bigger number, like not even too big, like 7 students, it becomes a little hard to list them all, right? 7 factorial is a fairly big number.
When
Okay.
I was solving, I realized like there's like a pattern to it. So like then I quickly got, since it's A and C together, it'll be like 2 out of 4, so it'll be 1 upon 2.
Okay. All right. That's fine. Okay. So let's discuss what Navya was just describing, right? So the total number of A's is 24. We all agree. Without any restrictions, 24. Now the favorable cases is where A and C are sitting together. Now what she's doing is she's locking up A and C together in a box. She'll put A and C together in a box, and then there's B, which is free floating, D, which is free floating. So she'll say, I don't have this concept of A and C anymore. I'm going to call them X. That box is labeled as X. And X, B, and D. And she says there are only 3 spots now. There are 3 spots where X, B, and D have to sit. So that we know, maybe X can be here, D can be here, B can be here, X can be here, D can be here, B can be here, all of that. So we know there are 3 factorial ways in which that can be done. And then she'll open the box. She'll open the box and say, between A and C, either you guys can sit like this or you can sit like this, right? So therefore, she'll multiply that by 2. So it's 2 into 3 factorial by 24. Okay, and that indeed is 12 upon 24, which is 1 upon 2. Does this make sense, guys? And this works for a bigger number. Let's say instead of this thing now, instead of 4, like I said, there are 7. Same thing. I'll put A and C in a box. Now A, B, C, D, E, F, G, right? Whatever the rest of the spots be, right? So there are 6 spots. I'll arrange them in 6 factorial base. And then I'll open the box. I'll arrange A and C in any way. The bottom will be 7 factorial. So this will just turn out to be 2 upon 7. Right? Yeah, does it make sense? I was going to say something else. Okay, let's do another variant of this question. Okay, let's finish this question. So you'll see me giving different variants of the questions given on the homework. Sandy, is this clear? Sandy, I cannot see you better fully. So with a few of you have this problem. When you duck down, I cannot see your full face. Can you adjust your monitor so that I can see your full central face? All of you. Okay, Sandy, does it make sense to you now? Okay. Okay, there is exactly 1% between A and C. Has anyone done this one and got an answer? Arav, yeah, go ahead.
I'm not sure, but I got 2 over 3.
Okay. All right. 2 over 3. Okay, Arav, tell me why 2 over 3.
So similarly to the previous question, I basically just drew out 4 lines. And then I figured out, since there has to be 1%, but there can be only 1% between A and C. The only 2 possibilities are if either A or C is in box 1 and then the next one, and the either remaining one is in box 3, or it could be A is in box 1 or C is in box, A or C in box 2, and the remaining one is in box, the 4th box. So that leaves 2 possibilities. But then the A and C can be switched out. It can be arranged in either CA or AC.
Understood.
So that's times 2. And then since there's D and C as well, those can be arranged in another
D and B. Yeah. Okay, you did. Okay, I understood the process. Overall, you got 2 by 3. I just want to go around and check. Others got 2 over 3 or something else. Suhani, what did you get?
I got 1 over 3, but
1 over 3. Okay.
because I counted, so I'm not actually sure how to do it.
All right.
without-
Any other answers? Navya, what did you get?
did the same method as Arav, but I got 1 by 3.
You got 1 by 3 as well. Okay.
Sorry, I just
No, I
rechecked.
got
Multiplied.
Okay. So multiple people got 1 by 3. Okay. So who? Okay. Let's discuss again. Same method. Just rub it off again. So like he correctly pointed out, there are only 2 possibilities, right? So if they have to have 1% in between, it could be either this spot or this spot. So let's go with this one, and then we multiply the answer by 2, right? If we do this, then symmetrically the other one is exactly. So if you choose with the spots 1 and 3 for A and C, first of all, between A and C, they can be swapped. So it's A and C or C and A between the first and the third spots. Now we just have to pick who among B and D is going to sit in the center. Let's say we pick B, right? Or we can pick D. So there are 2 ways in which you could have picked who is going to be sitting in the center. And then there's no other choice. The remaining person is going to sit in the last spot. Exact same thing will be repeated in the bottom case as well. So 2 into 2 into 1 that we had into 2 upon the total number of which is 24. So which is 1 upon 3. Okay, does it make sense? Now I'm going to extend the same problem for part B. I'm going to ask you guys. So there are 7 students, A, B, C, D, E, F, G. Okay, and can we repeat part B? Part A, we don't have to repeat. It's easy. Part B, can we repeat? Repeat part B for A, B, C, D, E, F, G. You can take a minute and do it, guys.
So I didn't understand how you got 2 into 2 into 1.
Okay, so I'll do it again.
Shouldn't A and C have to be locked? So
A and C have to be locked with a gap of one in between, correct?
Yeah.
Yes. So you can imagine them in a box with one other empty spot in between.
yeah.
So this whole box itself can either be here or here. Do you agree? So there will be 2 spots for the box to be there, right?
Yeah.
Now, once you open the box, A and C could be first and last or last and first. So there are 2 ways. 2 position for where the box itself fits, either 1, 2, 3 or 2, 3, 4.
Yeah.
And then within the box itself, who will sit in the center of A and C? Is it B or is it D?
So
Each
two.
of those questions has 2 as the answer.
Yeah, okay.
So repeat the exact question for A, B, C, D, E, F, G. Don't call out the answer. I'll call out who will tell the answer for this one. Okay. All right. Anyone has an answer? Can you raise your hand? The electronic hand. Okay. It should not be so hard. By now, you guys should have finished it. Veer, you have anything? Veer, can you hear me?
Can you just tell me why did you put the third 2?
The third 2 was who goes in the center? Is it B or is it D?
And the second one?
Where does the box itself fit? The box fits in 1, 2, 3 position or 2, 3, 4 position.
And the first one was?
When you open the box, where are A and C seated?
Oh, okay, got it.
Okay. Veer, I was asking you, were you able to figure out for A, B, C, D, E, F, G?
Not really, sir.
Okay. Oh, it's very logically similar to the with 4 people, right? Navya, do you have an answer for 7?
So I got 1200.
1200. It's probability. You mean 1200 upon something?
Oh yeah.
I mean, probably you mean 1200 upon 7 factorial. Is that what you mean? Just check.
Yes, I got 5/21, which is 1200 over 7 factorial.
5/21. Okay. All right. Let's hear from anyone else who got the same 5. Sanvi, did you get 5/21? I'm not saying 5/21 is right. I'm just checking what you guys have got. That's it.
I'm still doing it.
Okay.
Yeah, you simplified it's 5/21.
5/20. Okay. Okay. So let's discuss, guys. Okay. So we have a lot to cover. 1, 2, 3, 4, 5, 6, 7. Exactly same approach we'll take. So the box can start from here. That's 1, 2, 3 position. It can end here. Right. So the starting of the box can be in position 1, or the starting of the box can be as farther out as position number 6. So there are 6 starting positions for the box. Right. And now when you open the box, A and C can be left, right, or right, left. That's 2 ways. Now, who's the chosen person who will be sitting between A and C among the remaining 5? I can choose anyone in 5 ways. And then the remaining 4 people can arrange themselves in 4 factorial ways. You agree? Okay. So as simple as that. And of course, the denominator is 7 factorial. Now we can just see that 5 into 4 factorial is 5 factorial. So this is 5 factorial. 5 factorial into 6 is 6 factorial. In fact, we can see 6 into 5 into 4 is 6 factorial. So Navya, rather than deal with big numbers, try for cancellations, right? So this is 6 factorial into 2 upon 7 factorial. So which is
5 into
am I doing some mistake?
yeah, I got 5 into 5 factorial by 7 factorial.
Yeah.
Sorry. Oh, sorry. I made a mistake here. Right? This is the 7th spot. So you have only 5 you have only 5 spots for starting. Correct? Yeah. So 5, 6, 7 is the last box. So my bad. Sorry. Okay. So this should be 5. All right. So there are 5 ways where the starting position of the box can be. And then 2 ways where A and C can be left, right, or right, left at the far ends. And then, like I said, right, 5 ways, not 5 ways. Yeah, 5 ways to select who the person sitting between them will be, and the remaining 4 can arrange themselves in 4 factorial ways upon 7 factorial total. Now 5 into 4 factorial is 5 factorial. So I can cancel off 5 factorial with 7 factorial, leaving 6 into 7. And then this can be simplified further as 5 over 21. Yeah, Navya, question.
I do a different method which like basically just merges 5 into 4 factorial like, by itself. So I just do the unit method, like you take 3 numbers as 1 unit.
Yeah.
So then you just get, and then does that also work?
That works also. Yeah, that works. And then once you put A and C, literally you don't care. You don't have to go especially and see who is at the center. Spots have been taken by A and C, and they are either swapped this way or that way. Doesn't matter. The remaining spots, there are 5 people, arrange them in 5 factorial ways. So that's also another way to think of the same thing. Okay, does it make sense? Okay. Okay. Another variant of this question. What is the probability that okay, no, actually, let's come back to that later. I was going to ask what is the probability that A and C are not sitting next to each other. That in fact can just do it quickly, right? So the question is A and C are not next to each other. Not next to each other. It'll be simply 1 minus the answer for part A, because part A is A is next to C. The question that I asked right now is just 1 minus part A, right? Because either this will happen or that will happen for sure. So the probability is just 1 minus. Okay, all right. That was question 1. Question 2. Let me just paste it. Okay, coin is tossed, a square spinner ABCD is twirled. Okay, determine the probability of obtaining a head and a consonant. Ranveer, what did you get on this one?
Wait, so I haven't done this question.
Okay. Sanvi, how about, oh, Sanvi, you said you didn't have time to attempt the paper itself. Okay, Aditya.
So I got 3 upon 8.
3 upon?
8.
3 upon 8. Okay, Yuvam, you got the same? 3 upon 8. Okay, fairly straightforward, right? Head and a constant. So there are 2 independent things. So coin is tossed and some spinner is twirled. Whenever you have 2 independent things happening, the probabilities will multiply. So for independent events, probabilities multiply. Probabilities multiply. Okay, so you have half chance of getting ahead, and a consonant is what? Anything other than A is a consonant in this case, right? So 3 over 4. So it's half into 3 over 4. Tail and a C would be very similar, right? So half for this and 1/4 for this. A tail or a vowel or both. Okay. Suhani, what did you get on this one for the C part?
I'm not sure how, but I got 7 over 8.
7 over 8. Okay. Navya, did you get the same answer or something else?
No, so I made the same mistake initially, but then I got 5 over 8 after.
5 over 8. And what is that mistake? You added the probability for a tail and for a vowel.
Yeah, for both I did +1 by 8 instead of minus. So
Okay. All right. So let's see, right? So for getting a tail itself, so probability of tail, so probability is mentioned like that. Probability of tail is half. And probability of vowel is what? 1 over 4. Right? And Suhani, what did you do to get tail or vowel or both? To arrive at 7 over 8?
I added that to then multiply my half times a quarter.
Sorry, half plus
I
1/4
multiplied both of their probabilities and then added it to both of them.
Oh, okay, I see. Okay. So, and then you said probability of both. Probability of both is half into 1/4. Okay, probability of both is half into 1/4. Okay, and then you added up all of them, half plus 1/4 plus 1/8. Instead, as Navya was saying, you're supposed to subtract. Why subtract? So it's like saying this is your probability of getting a tail. Sorry, this is I would say Yeah, okay, fine. And this is the probability of getting a vowel, right? Right. So the getting a tail or a vowel is either the full tail or the full vowel. But when you add both, you're double counting this portion, which is where you got both a tail and a vowel. So you're not
Okay.
you're not supposed to add. In fact, you're supposed to subtract because you've added it twice. Right. So exact same logic. You figured out all of them, and then you said half plus 1/4, or you should say half plus 1/4 minus 1/8. Okay.
Okay.
Does this make sense? Alternatively, it is easy to do neither tail nor vowel and then subtract. So we can just say it's 1. Okay, I'll just do it in blue. 1 minus, okay, head and consonant. Okay. If I get head and a consonant, that means I have failed, right? Exactly. That's exactly what I don't want. If I get a combination of both a head and a consonant, then that means I neither have a tail nor have a vowel. So what is this? It's 1 minus. What is probability of getting a head? Half. Probability of getting a consonant was 3/4, I think, right? 3/4. So it's 1 minus 3/8, which will again give you the 5/8. Right. So in some cases, it's easier to do the opposite and then just subtract it from 1, because the number of cases that we don't want is easier or far fewer. Maybe not far fewer, but easier to calculate. Right. That's another bit. Makes sense. Okay. Okay. So going back to the previous question. I was just one other problem I was thinking of. Okay. So let's stick with ABCD itself. I'm going to ask one other question on this one. What is the probability that okay, we already did a C part on this, so I'm putting a D part on this. A and C are at the far ends. A and C are at the far ends. Okay, Veer, go ahead, please.
Would it be 1/6?
1/6. Okay. Anyone else agree or disagree with that answer? Suhani, your hand was up.
Yeah, I also got 1/6 for
Okay.
20.
Okay, Veer, can you explain your answer?
Yeah. So the way I did it was I said that assume A and C are at the ends.
Yeah.
And we can switch B and D around. That's 2 combinations.
Yeah.
And then we have another 2 combinations where C and A are switched, and the positions of B and D are switched, giving us 4, and we know that the total number is 4 factorial, thus we get 4/24, which is 1/6.
Wonderful. Any other way in which we could have done this? This is the obvious way. Any other ways people have in mind? Navya, you had something?
No, so similar method.
Similar way. Okay. So another way to think. So in permutation, combination, and probability, one nice thing is multiple approaches might strike you at different times. What I urge you to do is explore all the opportunities. Do once and do it in another way, or at least think through another way. So that way, what happens? Either both the methods will give you consistent answer, which will be very reinforcing and assuring that you're right, or you will get inconsistent answers, which will make you explore kuch to galti kar rahe ho. At least one of the methods is wrong. Probably both are wrong, but at least one of them is surely wrong. So always explore multiple ways. So one way I was thinking of this was, see, A, B, C, and D are there, right? So they are no special than the other B or D, right? They're also in the same group, A, B, C, D. Now, I could have picked only 2 people get to sit at the far ends, right? Only 2 people get to sit at the far ends, right? In how many ways can I choose 2 out of 4? It's 4 choose 2, right? 4 choose 2 so much? 4 into 3 by 2 into 1. So there are 6 ways in which I can choose 2, a pair out of 4. So this is the chosen pair. So there are 6 ways in which I can choose a pair which gets to sit at the far ends. Let's say the far ends are preferable, right? Preferred seats or something, right? Then it could be A and C as much as it could have been A and D or B and D and B and C and all that. So it's simply 1/6 that way also. Does it make sense? Another approach. So again, if you extend this to A, B, C, D, E, F, G, it'll be same thing. C, D, E, F, G. So there are 7 people, of which I'll have to select 2 special people. So that's 7 into 6 by 2 into 1, which is 21. So it's just A and C happen to be one of those 21 possible ways in which I can choose a pair. So it's 1/21. Does it make sense? Okay. Now, if you do the standard approach, what Veer was telling, so you'll still get the same answer, right? A and C have to be at the far ends. It can be either AC or CA. So that's 2 factorial or 2. And then the remaining 5 people have to be at the center in any way, doesn't matter, 5 factorial. If I divide by 7 factorial, I should get the same answer. 2 upon 5 factorial cancels off with 7 factorial with just a balance of 6 and 7. So this gives the same 1/21 that we got. But again, consistent results, therefore we are happy. Multiple approaches. There'll be many different opportunities for us to explore when there are inconsistent answers. Both approaches will seem very, why even two? There could be 3 different ways people might think in. And each of them will logically seem is fair, but somewhere there is a gap, right? And that's an opportunity for us to explore and fill that gap. Okay. That's question 2. Question 3. Probability that a man will be alive in 25 years is 3/5, wife 2/3. When the probability that both will be alive. So both are sort of independent, right? So it's just a simple product in that case, right? So 3/5 into 2/3. So 3/5 into 2/3. So it'll be 2/5 in this case. I'm quickly going through the ones which are fairly easy. At least one will be alive. Okay, Yuvam, what did you get on this one? At least one will be alive.
So for this, I think I got 13/15.
13/15. Okay, all right. Anyone else's answer matches? Did you get 13/15?
Yes, I did.
Okay, all right. Okay, at least one will be alive. So like I said, it's easier to do 1 minus probability that neither is alive, right? So 1 minus probability that the man dies is 2/5. Probability that the woman dies is 1/3, right? So it's 1 minus 2/15, which is same as 13/15. Yuvam, is that what you did?
Yeah, I did this exact same thing.
Okay, only wife will be alive. So it's 2/3 for the wife to be alive, and we want the man to not be alive. So it's 2/3 into 2/5. Okay, easy. Let's move on. Question 4. In a group of 40 students, 22 study law, blah, 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 economics, this, that. Determine the probability that a random chosen student studies both economy and law.
Sir, I'm sorry. What was the answer to 3C?
Oh, okay, okay. No, you don't have to be sorry. So I just skipped because fairly easy, right? 4/15, I think.
Yeah, got
Yeah,
it.
4/15. Okay. All right. Question 4. Group of 40 students, 22 study economics, 25 law, and 3 study neither. Okay. Determine the probability that a randomly chosen selects both economy and law. Ranveer, what did you get on this one?
So I did the last one, but I didn't get this one.
You did the 4C, is it?
No, I did the third question, but I didn't.
Okay, you didn't do the this one. Okay. What about Suhani? What did you get on 4A?
I got 1 out of 4.
1 out of 4. Matches with any other answer? Anyone else? RF, same 1/4.
So yes, I think I just drew the Venn diagrams and then.
Okay. Navya, how about you?
Yeah, same 1/4.
Okay, let's draw the Venn diagram. So economics is here, law is here. Okay, and then there's some overlap, and this is the total 40. So all of you know this Venn diagram business, right? So there are 3 of them who are sitting out here. Now this is 22, this is 22, and this is 25, right? And this is the portion which is X. So we know 22 plus 25 minus X will be the union of economics and law. So this will be the 2 circles put together. plus 3 is your 40. So we can find what the overlap is, right? From this is 47, 50, therefore X is 10. So there are 10 people sitting for studying both, and then 12 exclusively economics. And then if I'm doing some mistake, please call out, guys. 15 here, and then 3 which is outside. Now with this diagram, anything can be answered. Both economics and law is 10 out of the 40. Okay, at least one of these subjects, which means what? In fact, we don't even have to do anything to answer the part B, right? At least one of this is 3 out of 40. Sorry, the 1 minus 3 out of 40, right? Anyone but other than the 3 who study neither. So it's 37 upon 40. Economics, given that he or she studies law. Aditya, what did you do on the 4C?
So I didn't understand the difference of this question with the A one.
Okay, no, now, so this is called conditional probability. So this is a term called conditional probability. That means, so it's like asking, what is the probability? How many of you know Mumbai? Okay, fine. Few people are outside Mumbai, right? Okay, fine. What is the probability is raining in Mumbai? Could be one question. What is the probability is raining in Mumbai given it's raining in Thane, right? Thane is a nearby town or city, whatever, right? A very high chance, right? Because if it's raining in Thane, Mumbai is very, very close. So it's a high chance that it'll be raining. So that's called conditional probability. You have some extra information. It's still a probability. It still has to be between 0 and 1, but it'll be a higher probability than without conditioning. Is that clear, Aditya? Conceptually, is that clear? Right?
Yes.
Now, economics, given that he or she studies law, which means given you are in this bucket who's studying law, what is the probability that you're studying economics? So it's the 10 who are studying economics out of the 25 who are studying law. 10 who are studying both, actually. So it's actually, the way it's written is probability of economics given, it's written like this, conditional probability. So what did we do exactly? We did what is the overlap region? Only then you can be selecting economics and law, because this person must be effectively studying both, right? But you're normalizing for the fact that this person is already studying law. So he has a smaller denominator, therefore a higher probability. Does it make sense, guys? So 10 over 25. Right? Okay, so let me ask a question on conditional probability again in this one, on the same thing. What is the problem?
This one.
Okay.
I understand the 10, but not 25.
Okay. Given he or she studies law, so which means you're telling, forget the rest of the universe. Your universe is only these 25. In this 25, you have to be among the 10. That's it.
Oh, okay. So you have to study law, but then you also have to the people
Exactly.
who study economics out of the law is
Exactly. Yeah, because the denominator is the probability of people who are selecting law. And you can replace probability with count in this case.
Yeah.
So like you said, you have to study law, but among that group, what is the select group which is studying economics also, which is what the formula also tells.
Yeah.
Intersection of E and L among those with L. Okay, does it make sense, guys? Now for the same problem, I'll ask another question on conditional probability. What is the probability that someone is, okay, I'll just say probability that someone is not studying law given he is not studying economics. Okay, so given is not studying economics, what is the probability that he's not studying law? My handwriting is very, very clumsy, but you guys understand, right? That's good.
Is it 5 by 6?
Okay. All right. 5 over 6 is one answer. I haven't worked it out. Let's do it together. We'll wait for other answers. Okay. Anyone else, guys? Veer. Drishit.
Yes, I agree. I got the same.
Okay, Drishit.
Yes, I got the same thing.
Yeah. So our universe is now the people who are not studying economics, which is the 12 plus 10, the 22 people, right? So this is our universe of people who are not studying economics. Among them, right, 18, right? Yeah. Among them, which are the people who are not studying law, the three which are outside of both the buckets, which is indeed 1/6. Okay, well done, Navya. And others as well. Okay, cool. That was question 4. Question 5. So
So I
this,
have
yes.
a question. So I think we said 5/6, and because you said it's people who are not studying economics, you took the people who are studying economics.
Sorry, I forgot what this 5/6 I wrote was right now.
Was
I'm
the
sorry.
answer we agreed on, I think.
So sorry, Arab, I'm not understanding your question. Please again.
Since the question says given that he is not studying economics, isn't it 18, which is including just the people who are studying neither and the people who are studying only law?
Okay. So probability that, okay, not studying economics is not studying law. So that's denoted as L dash. L dash means the complement of L, right? Given not studying economics, right? So far so good. So which is the probability that you're neither studying law nor economics, given you're not studying economics. Do you agree? Okay. Now this denominator is there are how many people are studying economics? 22. So this denominator is 18. Well, 18 over 40, but the over 40 gets cancelled everywhere. So this is also something over 40, right? So this is neither studying law nor economics is 3 out of 40, right?
Oh, okay. Yeah, I understood. Sorry.
Yeah, okay. But by the way, I did write some 5/6 at the top. I don't know what that was. Maybe it was, well, talking about something else. I don't remember what that 5/6 was. Okay. Question 5. Probability that a particular salesman will leave his sunglasses in any store is 1/5. Suppose the salesman visits 2 stores in succession, leaves the sunglasses behind in one of them. What is the probability that he left in the first store? The question is very interesting, right? So he enters a mall, whatever, right? There are 2 stores in it. So 2 stores in it. So initially you see this guy walking with glasses. I don't know how to draw glasses, but right when he comes out, he does not have glasses. So which means he has forgotten. So let's say you observe him going in, right? You are standing outside, and what happens in the mall, you don't know. You observe him coming out without glasses. Now you're wondering in your mind, you don't know what happened inside the mall. There were 2 stores, right? Store A and store B. What is the probability that he left in store A is the question. Okay. Yuvam, yeah, go ahead, please.
The probability. Yeah, so I did some tree method. So I got 1/10.
1/10. Okay. What is the probability that he left the sunglasses in the first over? First 1/10. Okay. Anyone else?
I got 5/9.
5/9. Okay. Yeah. Without thinking too much, I can tell you that 1/10 seems very small, right? See, that means you're saying the probability that the salesman left his glasses in the second store is 9/10, because only one of the 2 events has happened. He's definitely left it somewhere. If you're saying it's 1/10 for the first, then it's 9/10 for the second, right? So that seems very disproportionate. Further, another argument would be the probability should have been higher for him to forget in the first store than the second. Intuitively, if you see, right? Intuitively, if you just see, for example, instead of 2 stores, let's assume the mall had 100 stores. Store 1, store 2, store 3, all the way to store 100. Again, the same professor, you see him walking with glasses. You see him walk out without glasses. Now you're wondering what is the probability that he left it in store 1 versus what is the probability he forgot it in store 100. More likely he forgot it in store 1, because for him to forget in store 100, He must have not forgotten in all of these intermediate steps. Only then he had an opportunity to forget in the 100th store, which he would have forgotten. He should have forgotten. So for him to forget at 100, he has to cross so much hurdle. Whereas for him to forget in store 1, it's easier actually. So intuitively, for 2 reasons, Yuvam, again, this is not just Yuvam, right? Intuit out something before, when you have an answer, very likely it'll be wrong, right? All of us do mistakes. I do mistakes also, but intuitively it should make sense roughly, right? It cannot be such a small number like 1 by 10, because that means the probability that he left in store 2 is 9 over 10. That's first reason. Second, it should be more than half for sure, right? So Navia's answer definitely passes both of those. It's more than half, right? And roughly around half, right? So let's see whether we are able to get that answer or someone else. Any other answer? Aditya, did you have anything? But the intuition is clear to everyone. Why I'm saying this? Swani, you're with me?
So I got
Yeah.
1 over
1 over?
8.
Again, for the same reason as what Yuvam called out, without thinking too much itself, I'll say that's plain wrong. But do you understand my logic in saying it's wrong?
Yes, so I just multiplied the probability that he left it in the first row times that he didn't leave it in the second.
Okay. So more or less, that's what. So basically, he is here. So he's entered the first store, right? He could have forgotten with probability 1 by 5, right? He could have retained it with 4 over 5. So let's say, so this means these are let's say this is the state where he still has, what shall I say for the state? He has glasses, and then he is, oh my God, I'm just struggling for a letter where, okay, yes, no, I don't want to say F for forgot, right? He does not have glasses, so he's blank, right? So blank is, right, and he's wearing glasses is G. So he's entering wearing G, right? And then he forgot in the first store, and then he has become blank, or he's still having the glass, which is still G. Now he enters the second store, right? If he is already blank, then there's nothing for him to forget. He'll still continue to be blank. So with 1 probability, he'll come out blank without glasses. Whereas if he didn't forget, then with 1/5 probability, again, he could have forgotten and come out blank. Or with 4/5 probability, he could have continued without forgetting, which means he has the glasses. Now, where are we in this question? In this question, we are saying that he did walk out blank, which means he's either here or here. Which means either he came through this path or he came through this path. Right? Right? So collectively, what is the probability? So it's 1/5 into 1 for the first path plus 4/5 into 1/5 for the second path. So for him to just, so the question is, what is the probability that the salesman came out without glasses? Then the answer would be like what I stated here, right? Which is the sum of these two, which is 5 plus 4, 9 over 25. This will be the answer to the question. What is the probability that he comes out without glasses? That's 9 over 25. But now this question is saying, you don't have to tell me that. I am telling you that he did forget. You just tell me what is the probability that he forgot in the first row, which means this 9 over 25 is now the denominator. Given this event happened, what proportion was due to him forgetting in the first store, which is actually this process, right? So the proportion of the first store was 1/5, right? So indeed, this comes out to be 1/5 into 25 over 9, which is 5 over 9. Does this make sense to everyone, guys, intuitively? Veer, does this make sense to you?
Yes, sir.
Okay. All of you okay on this one? Ranveer, you're with me? Arav? Arav is away, looks like. Okay, all right. I'll wait for a few seconds. Suhani, you're okay?
Yeah.
Okay. Yeah, I don't want to repeat it with the other one, but I could ask another question, right? So, how are we doing? I want to finish this paper also, but all of these are good questions. Okay, fine. Let's move on. There'll be ample opportunities to do similar questions. Question 6. Team of 5 is selected. 6 doctors and 5 dentists. Determine the probability that consists of all doctors. Aditya, what did you get on this one?
So I got 1/6.
1/6. Suhani, same answer or different? Suhani.
Oh yes, I wasn't able to do this question because
Okay.
I don't have time for this one.
All right. Anyone agree or disagree? Yuvam? What?
Didn't do this one.
Didn't do this one. Navya, what about you?
I got 1/7.
1/7. Okay. Let's discuss. 1/7. Okay. A team of 5 is chosen randomly from 6 doctors and 4 dentists. So 6 doctors and 4 dentists. Oh shoot, doctors and dentists. Oh my God, why can't they choose different professions? Both are D. Okay, I'm going to call the dentists as T. Dentist, right? So I'll say T. So 6 doctors and 4 dentists. Okay. Determine the probability that consists of all doctors, right? So the denominator would be of there are 10 people, I don't care what their profession is, I have to choose 4 people. That's the number of ways in which I can select 4 out of these 10 people, right? 5, sorry, team of 5 have to be selected, right? So if I have to select 5, it can be in 10 choose 5 ways, right? Now, the favorable cases are those where all of them are doctors, which means 6 choose 5. I should have selected 6 choose 5. In way 6 choose 5 ways, I can selected doctors. Okay, so this is now just numerical, right? So 6 choose 5 is same as 6 choose 1. Selecting 6 is, and then the denominator is 10 into 9 into 8 into 7 into 6 upon, so upon will go upper 5 factorial, right? 5 factorial is 120. Okay, so okay, I'll just replace it with 120 so that you can start cancelling off. So 120. Okay, so the 6 and 6 will cancel. 10 and 10 will cancel. 9 8s are 72. So it's 6. So it's 1/42. Right? Does it make sense? Navya, how did you get 1/7? Can you explain?
So I also did the same method. Like I did 6C5 by 10C5.
Okay, maybe some calculation error in either, or have I done something wrong? Can I check? Let me just check. 6 upon 10, I'll redo the same thing. 9 into 8 into 7 into 6 upon 5 factorial. 5 factorial is 120. So I'll redo this again. 12 cancels with 72 6 times. This 6 cancels with this 6. 1/42 indeed. Yeah.
Yeah, I made it the 6 in the I didn't multiply by 6 in the denominator.
Okay. All right. What is the probability of at least 2 doctors? Can you all do it now that we know this logic of choosing and all that? Can you take time now to do it, all of you? Many of you have not done it. Now you know how choosing and all works. Can we do B part? I'll give you a minute, all of you. Okay. How are we doing, guys? Aditya, you have an answer?
So not yet.
Okay. How long more do you guys need? 45 seconds more. Yuvam? Yeah.
Sir, is it 6 choose 2 upon 10 choose 5?
Okay. 6 choose 2 upon 10 choose 5. Okay. Now, this would be the answer if what is the probability of selecting 2 doctors, then that will be the answer, right? But the question is at least 2 doctors, right?
Can we choose like more than 2 also?
Correct. That's what at least means, right? Okay. Yeah, Navya, what did you get? Have you got a numerical answer?
I got 13 by 126.
13 by 126. Okay. Do people want some more time, or if someone is asking
Can
me to hold?
20 seconds.
Okay.
Oh, so I got 209 over 126. I didn't check if it can be simplified.
9 over 126?
Also 209 over 126.
209.
Yes.
How can this number be greater than 1? It's a probability, right?
Yes.
All right, Veer. Yeah.
Yeah, I got 81 over 126.
Okay. All right. We have a collection of answers. Let's discuss. Right. So this is doctors. This is dentists. Right. So dentism is called TIS. Right. Okay. D and T. Now we need 5. Right. So it can be either at least 2. Right. He wants any of like 2 and 3. I'll show you 2 ways of doing this. Right. So or 3 and 2 or 4 and 1 or 5 and 0. Right. Now I'll tell you upfront, this is a long way, but let's still do it. And then I'll tell you the shorter way as well. Okay. If you have to select 2 doctors and 3 dentists, there are 6 doctors and 4 dentists, right? So it's 6 choose 2 into 4 choose 3. Upon is always same. Upon is always 10 choose 5. So I'm not going to write that again every time, right? And this would be 6 choose 3 into 4 choose 2. This would be 6 choose 4 into 4 choose 1. And this would be the first answer to the first part, right? 6 choose 5. There's nothing to choose from the dentist. So 4 choose 0. 4 choose 0 is same as 1. So as good as not multiplying. 4 choose 0 is same as 1. Okay. And then you figure out all of these numbers, add. So which is obviously wrong. Obviously long, not wrong. Long. L-O-N-G. Okay. A shorter way would have been, what are the other cases? 1 and 4 or 0 and 5. Okay. But 0 and 5 is not even possible because there are only 4 dentists. How can we pick 5 dentists? This is still possible. Okay. And this is the only case I have to subtract from 1. If I'm assured that it's not this, then there's at least 2 doctors. So what is the probability of 1 doctor and 4 dentists? So 1 doctor and 4 dentists, 6 choose 1 into all 4 dentists can be in only one way. 4 choose 4. So this is very easy, right? So 6 into 1, only 6 ways. You have to literally select 1 doctor and then all the other 4 dentists, right? So this is the probability of selecting 1 doctor and 4 dentists. Now anything other than this, so 1 minus 6 upon the 10 choose 5 that we saw should be the answer, right? Now let's simplify what 10 choose 5 is. So let's simplify this. So we did that here, right? So 6 upon 10, 9, 8, 7, 6 upon 120 at the top, right? So same thing, 10 gets cancelled, 12 gets cancelled, 6 gets cancelled, 1 upon 42. 1 upon 42, right?
Why did you do into 120?
No, it's divided by 120, which goes to the top. What is 10 choose 5, beta? 10 choose 5 is 10 into 9 into 8 into 7 into 6 by 5 factorial, right? So this is the denominator, right? So when you put this in the denominator, the 120 upar jayega na?
Correct.
Yeah. So, all right. So again, correct me if I'm wrong. If I'm doing some mistake in the cancellations, it's 1 upon 42. Therefore, it's 1 minus 1 upon 42. So it's 41 upon 42. Uh,
I don't understand how that makes sense because isn't that just like no doctors?
n-
Because in the previous one we got 1/42. So
the previous one we got 1/42. Okay, you mean for the A part? For the A
yeah,
part we got 1/42. Okay,
I-
what is this? 6 choose. We'll say literally 6 choose 6, right? 6 choose 5. Sorry, 6 choose 5. So the previous answer was 6 choose 5. We have to literally select all doctors upon 10 choose 5. Correct. Now
Yeah.
here it's coincidentally we are saying we don't want the case where exactly one doctor is selected. Because if we eliminate that possibility, then at least 2 doctors are there. Because one doctor to assured hai, 0 doctors cannot be there because there aren't 5 dentists. So only case where you don't want is 1 doctor. And it just so happens that 1 doctor is same as 5 doctors.
Yeah,
So this happens to be same as the numerical value that you calculated in the first one.
but it's different.
Yeah, but for different reasons, right?
Yeah. Okay.
And therefore it's 41/42. Does it make sense, Navya? What is the mistake you made, Navya?
I did 5C2 and then 5C3 and so on, and then I didn't consider 6C2 and then I didn't multiply with 4C3.
Okay, so you basically added 6 choose 2 plus 6 choose 3 plus 6 choose 4 plus 6 choose 5.
Yeah, but I did 5C2, 5C3, 5C4.
Oh, okay. Meaning we misread the question, assume there are 5 doctors.
No, I just thought that I was supposed to, since there are 5 I have to pick, I
Okay.
just choose.
Okay.
I was
All right. Understood. And what about, sorry, who called out 81 on 126? Veer, was it you? What was the mistake you did?
I'm not sure, so.
Okay. But is this method convincing, what I just described now?
Yes.
Yeah, makes sense? Okay. All right. That was question 6. Question 7. For 4 numbers. What is the probability that X is? X is the second largest of the numbers selected. What is the probability that X is 2? Drishit, what did you get on this one?
So I didn't get this.
Why? 4 different numbers are selected. What is the probability that X is the second largest? X is the second largest, right? Just think intuitively, Drishit.
Yeah.
If 2 has to be the second largest,
Yeah.
what should the other numbers be?
So one second.
Yeah, Yuvam.
The probability is like not possible because 2
Exactly. Exactly. That's exactly what I was asking him, right? So if 2, so which means there are 4 numbers, right? A, B, C, D, 4 numbers selected. If this is 2, then we need 2 numbers below 2, which we don't have. So this probability is 0. Agreed? Okay. Yeah, this does make sense. Probability is 0.
But why can't oh never, yeah, I got it. Yeah. Okay.
Yeah, makes sense. Okay. What about part B? Ranveer, did you do this one? Probability of getting a 7 as the second largest.
So I didn't understand this question.
Which part was not clear? Did you spend enough time going through?
Didn't get how to like operation.
Okay, so which part is not clear? It's in English. It's very clear, right? 4 different numbers are randomly chosen from a set of 1 to 10. Guys, you need to give enough time. You cannot skim through the problems and just expect it'll fall on your plate. Okay, either accept that you didn't give time, as one of you did in the beginning of the class, or say like I didn't understand, or don't give this reason like I didn't understand the question, right? It's not a confusing question at all. Sorry, I'm being a little harsh on Ranveer, but same applies to others in other situations as well, right? So it's not a confusing question. X is the second largest. You're randomly selecting 4. X is the second largest. What is the probability?
The point where I got 8, 9, and 10 or larger, but then I don't really know what to how to
Okay. All right. Okay. So good. That's a different way of studying. You understood the question. You don't know how to solve it. That's a different issue. It's not like you didn't understand the question. Okay, cool. That's fair enough. Well, what about Suhani? What did you do on this one?
Yeah, so I kind of like got a bit stuck. So I know that there's like three numbers that could be greater, like 8, 9, and 10 than 7. So it could be like, and then 3 possible combinations. So like 3 into 3. And then I think for smaller than 7, it would be like 1, 2, 3, 4, 5, 6. And then you like multiply that with how many possibilities, but I wasn't sure like how to proceed from
Okay.
getting those numbers.
All right. Fair enough. Arav, what did you get?
So similar to Suhani, I just worked out the main I just thought about the logic of the question. So
Okay.
for greater than 7, there are 3
All right.
terms.
Fine.
Yeah.
Okay. Sounds good. Okay. Anyone with a numerical answer to share?
3 by 14.
3 by 14. Okay. 3. Anyone else? Veer, any numerical answer?
No.
Okay. All right. So 7 is here, which is the second largest, A, B, C, D. So we must select 1 of 8, 9, or 10. And then from the remaining 1, 2, 3, 4, 5, 6, I must select, right? So I definitely want 7. So let's list out the number of possibilities in which I can select, right? So I must definitely select 7. So that's done. From 8, 9, and 10 of the 3 numbers, I have to select 1. That's 3, choose 1. From the remaining 6, 1, 2, 3, 4, 5, 6, I'll have to select 2. These are my favorable cases. 7 is already chosen. So there's nothing for me to choose. I'll write a 1 here because there's no option. I have to select 7. So that's one way. I literally have to select 7. Of the total number of possibilities is just 10, choose 4. And now rest is simplification, right? So 3 is just 3. 6, choose 2 is 6 into 5. 6, choose 2, I'll do it separately. 6 into 5 by 2 into 1, which is 15. So it's 3 into 15 by 10, choose 4. Also, I'll do it separately. 10 into 9 into 8 into 7. Okay, fine. I'll write it here. 10 into 9 into 8 into 7 upon 24, which Yuvam will go up now. Don't ask the same question now again. 24, 72 is 3, right? And then this 3 that cancelled with this 3. This 3 gets cancelled. This 2. So it's 3 upon 14 indeed. Well done, Navya. Okay, 3 upon 14. Does this make sense, guys? Everyone? Ranveer, does this make sense to you now?
Yeah, more or less.
Oh, no. Why do you say more or less? That means I didn't do a good job.
I just like practice it more.
I know. Okay, yeah, definitely you have to practice, but this makes sense, right? Logically, it makes sense how you approach, right? So similarly for 9, oh, sorry, I don't know why I had to erase this. Anyway, for 9, it should be very similar. I'll have to select 10. There's no other choice. So I'll just write it out in this order. So 9 is here. 9 is here. So I have to select 10. I have no other choice. So it's much easier problem now. From the remaining 8, I'll have to select 2. So it's 8, choose 2, which is 56. Oh, sorry, 56 upon 2, which is 28. 28 upon the denominator, 10, 9, 8, 7 upon 24. Maybe I should have calculated this and kept handy. So this comes to 4 over 30, 2 over 15. Navya, is this what you got as well?
Yeah.
2 over 15. Okay, cool.
4 over 15.
Sorry, 2 over 15.
I got 4 over 15.
Oh, is it?
Got 2 over
Did it
15.
is a mistake?
No, it's
4.
2.
Yeah, I think it's 2 over 15. Just check your answer once.
Let's check below. I wrote it below.
Okay. All right. All right, let's move on. I was thinking of another question in the same. X is the second largest. Okay, all right. Let me ask you one question on this one. Okay, so you form a 4-digit number, okay, by selecting 4 different digits from 1 to 10, right? I mean, nothing is common to this problem other than it's 1 to 10, right? From 1 to 10, I select 4 random digits. So this first part is exactly same. 4 different random numbers are chosen from this, and I make a 4-digit number by lining them up. Okay. What is the probability that the digits will be in the increasing order? what is the probability that the 4-digit number will have its digits in increasing order? Question is clear to everyone, right? If anyone is not clear on the question, please ask now.
So can you repeat one last time?
Okay. So from these 10, I select 4, just like the first statement says. I form a 4-digit number. What is the probability that the digits in that 4-digit number are in increasing order? Sanvi, what do you think? You've been very quiet today.
Sir, I'm sick.
Oh, sorry to hear that. What happened?
No, everyone in school has a cold or a cough or something, and now they've given it to me.
Okay.
Worst timing possible, like exams start next week.
Okay.
Hmm.
All right. But anyway, so this, you're in class right now. It's just, you just have to think through and just answer. Or anyone.
Calculating. One sec.
Aditya, are you back? Are you connected back? I don't know when I lost you.
Yes, so I disconnected like in the middle of the 7th sum.
Oh, okay. All right. That's fine, Aditya. I don't want to repeat the same question again one more. You can just watch the recording. Okay. Anyone has an answer or we'll discuss? Navya, you have anything?
No, so I didn't get this one.
Okay. Anyone wants me to hold for 20 seconds? Middle of thought process. Okay. All right. So some random 4 digits are going to get picked. Doesn't matter. Let's say the digits picked are 3, 8, 1, and 7. Doesn't matter, right? Whatever 4 digits get picked, right? They can be arranged in 4 factorial ways, of which there'll be only one way in which there'll be an ascending order, right? It has to be literally 1, 3, 7, 8 is the only possibility with any 4 chosen numbers. Doesn't matter. It's only one way of the 24 ways in which you can arrange them. So it'll just be 1/24. As simple as that. Does it make sense? So you can pick from a set of 100, doesn't matter. Of course, when you pick 100, there's no digits. So there's only digits. Oh, actually, maybe I should have given 1 to 9 because 10 is technically not a digit. But doesn't the answer is 1/24. Because if I pick, like, just to repeat what I said, if I pick any digit, any 4 digits, I can, there's only one way in which I can arrange them. 1/24. Does it make sense, guys? Okay. Small variant of this question. Now, okay, I'll just restrict to 0 till 9. In fact, I'll just say 0, 1, 2. I'm including 0 all the way till 9. Okay. Again, the same process. There are 10 numbers here, by the way, from 0 to 9. I'm selecting 4. I have to arrange them. Increasing order again. But the number cannot start with, oh no, actually that doesn't make sense. Forget this question. Forget, please. I was just being stupid. Okay, question 8. Question 8. Maybe do we have time for this one before we wrap up?
Repeat the answer for the previous one.
Yeah. So
Okay.
any four digits can get selected. Let's say it's 2, 6, 1, and 7.
Yeah.
Whatever 4 gets selected, there's only one way in which you can arrange them in increasing order, right? Of the 24 ways.
Yeah.
That's it.
Oh, okay. So then.
Okay. When Peter plays John at tennis, the probability that Peter wins the game is P, and probability that John wins his service game, right? Service game is Q, right? So P is greater than Q, and P plus Q is greater than 1. All right. So does it make sense? If you want to just visualize, just put some numbers. Let's say P is 60% and Q is 50%. That way, your array for P is greater than Q, P plus Q is greater than 1. But let's keep variables. But if you want to understand, you can just keep in terms of numbers like this. Okay, Peter will win at least 2 consecutive games out of 3 when he serves first. In the interest of time, let me just quickly go through it. And if you have done it, you can just check your answer. Peter will win at least 2 consecutive games out of 3 when he serves first. Right? So that in tennis, they serve alternatively, right? Or what is it? Oh, when he serves first. Okay, I was just wondering who's serving first, and the answer is right here. Okay, so Peter is serving first. So first of all, he must either win and lose, or lose, win and win, or he can win and win. All of these are acceptable, right? So that's when he has won at least 2 consecutive out of 3. Okay, now for each of them, you can give the probability. What is the probability that he wins when he serves first? It's P. What is the probability that, so this will be, this is Peter serving here. This is Peter serving, and this is John serving. This is Peter, this is John, and this is Peter. Right? So Peter has to win. This is, in fact, I'll put the probabilities below this. That way it's easier. I'll erase this. So Peter has to win, which is probability P. In this one, Peter has to win. So it's 1 minus Q. Remember, John is serving, therefore probability of him winning is Q, but you want Peter to win. So it's, and then the loss for Peter here is when his won't serve. So his won't serve, his losing is 1 minus P. Okay, so that is the first case. Now he can also have loss, win, and win, which will be exactly same, right? Because in his serve, he's losing. So it's 1 minus P, and then 1 minus Q, and then here in his serve is winning. And then the other cases where he wins, and wins. So for him to win in his own serve, it's P. For him to win in the other guy's serve, it's this, and his own serve back, it's P. Now we just have to add all of them. That's it, right? So when I add all of these 3 quantities, you can simplify. So it looks like P can come out of all of them. There's P here, there's P here, there's P here. 1 minus Q is also there in all of them. So look for simplifications, guys. So P and 1 minus Q can come out. The only missing term in this case is 1 minus P. The second one is also 1 minus P. In the third one, it's just P. So when I add all of them, I get a 2 minus P in the numerator here, right? So P into 1 minus Q into 2 minus P becomes the probability. Does this make sense, guys? Yeah. Okay, all of you good on this one? I was just going to ask something, but it's fine. Okay, let it be. Okay, all right. Let's meet in next class then. You finish the rest of the questions, of course. And then mostly we are done with the probability and permutation combination basics. Now from here on, as we do topical questions, these are like sort of warm-up questions, right? Obviously AMC10 questions, we'll do topical questions. I'll assign some homework on probability and permutation combination with what you've studied so far. Okay, but finish off the rest of this, whoever has not finished. Okay, see you next week. Bye. Oh, sorry, Arav, you had a question? Oh, okay, bye.